Right, folks, so we're going to move on to box 30. As I said last time, we'll be doing one of our sets, like the ones which get donated, and then a customer set, because we've got a bit of a backlog. We've got a bit of a backlog with the donated sets because we've done a lot of customer repairs. So it's going to be back to box 24 tomorrow to do the other sets kindly sent in by Alan. If it's doable, it's a Fidelity 1000, but there's some bits missing. So we're going to move on to box 30, which is a customer repair for Dave. He's an end user, but he's got a vast collection, and he sends an awful lot of sets in. So, Radiomobile 201, box 30. I think this is straight from eBay. I think it was sent to us via the eBay vendor, which is always good. It cuts out some post. So it's got the side bobbles, which I must remember to... I'll tell you what, I'll put them in the box, or it won't have them by the time it leaves here. We've got a factory original mic, and we've got a stub of a power lead, which is broken at the business end. There's absolutely nothing I can do with that. So just there's the break. We'll prove it. Now these are power leads that are readily available, so they're not one we manufacture, like the Maxcom one or the Amstrad square and round one. No, it's as dead as a dodo, so that can go in the box as well. At least there's a fuse holder on that. There's a trimming tool there that shouldn't be. So we'll use our bit of a stub of a power lead I want it to be nice if this actually worked and I just had to do a tune-up. I don't remember the square clip on that. So we're lit up, we're on channel 28, we'll now be on channel 20, centre of the band. I'll go and get a sheet. So, with a blank sheet, we'll switch picture in picture on, then you can look at the meters. I think that's come up on the screen. Oh, it transmits, and it's doing... doing spot on 3 watts. So let's go over to channel 40. It's doing 4 watts, 3 watts, sorry. Channel 1 is doing 3.05 watts. Back to channel 20. Current consumed 977 milliamps. And on low power, which is it on the back? It is. It's doing 150 milliwatts. And just out of interest, it's drawing 430 milliamps. So the deviation, wallow, there is no deviation, 1 2 1 2. We'll come back to that in a moment. Frequency, $27,790.75. So that does need coming up. And we'll set the receive frequency to the same, 27,790.75. Just like that. I can't hear anything. It's receiving. I've got a full set of things. I don't think the mic works. So if we get our standard Cybernet mic, very, very low audio. So we'll plug in our PA speaker rather than it go through the test instruments. Very low strangled audio. So we'll put the instrument speaker in. Might still be able to get a reading. Yes, we can. There's enough volume to get a reading. So it's doing 0.58 microvolts. Which is fine. For 10 dB, oh, let's put that on the screen for you. For 10 dB, it's doing 0.39, and for 20 dB, well, I can't get a reading for that because of the fault on the set. Very low strangled RX audio. So for S9, let's see where, if that's S9, and I'll have to look at the instruction book, which I'll have on file somewhere, hopefully, or for the Cybernet Beta 1000, or for the Ford Roadmaster 201, 501 or something. I need to know what they relate to. Just 1, 2, 3, 4. I don't know whether it's 1, 3, 5. Oh, it's not going to be. It could be 3, 5, 7, 9, or it could be 3, 5, 9 plus 30. I don't know. So I need to check that. But it's the fourth light is lighting at 55 microvolts. So light for 55 microvolts, and on transmit, make sure we're back on normal, is a full set. So doesn't have one, that's okay. Can't prove that, can't prove that, that isn't there, and we don't know yet. So just look at squelch. So squelch on full, it is 25 microvolts. I'd like it a bit stronger than that. And for the sensitive end, I hate these concentric controls. Set threshold on the radio. Straight in. Coming in at point 0.2. It doesn't actually seem normal. So we'll go back to deviation. Now we've put the standard replacement mic on. Voila, 1 2 1 2. So I think we've got a common denominator here. Let's get our little monitor receiver. Testing 1 2 1 2. And the common denominator is that we've got no audio on transmit, and we've got dodgy audio, very dodgy audio on receive. Anyway, we'll work with the standard replacement mic, so we're not doing a variable on a variable. And most of these sets were shoved in somebody's loft or garden shed when they stopped working anyway. So it's, you know, it's like discovering a... I was going to say an old TV, but that's a difficult one in the UK because of our change of standards in the 1960s from 405 lines to 625. So unless you're a real enthusiast, you can't really do anything. I think the earliest television sets you could actually watch a picture on today would be 1963. But I know there are enthusiasts who go to a lot of trouble to buy or build standards converters for the 405 lines. What I was going to say is most things get put in the loft because they don't actually work, but they were probably repairable at the time. Right, so that's that. What I'm doing is trying to feel the temperature of the audio IC. So basically, the Cybernet 135 chassis, which this is the same as the 134, but a more compact layout with fewer option facilities and negative earth only. And that looks like factory jiggery pokery. I'll tell you what we will do. I mean, this is like fiddling while Rome burns. We'll put it on frequency. Just make sure I'm doing the right thing here. There's the reference crystal. Yeah, it looks like it goes to that. hate to be altering the VCO, which I've no intention of touching. There we go, 2779125. Well, I think we're going to have to get to the bottom of receive. We've got a circuit somewhere. We haven't got much more. Right, let's plug the... I think it's best to work with the PA speaker we have mounted on the wall. So, usual finger job, using my body as a without looking at the circuit. We'll just go down there with plenty of audio there. By the way, these resistor networks here get very, very hot. So don't think there's anything abnormal. You know, you could burn your finger on those. That's interesting. So why have I got... You know what? I think we've got a dry joint on the audio IC. Let's cut the power, because when I touch there, I've got no noise. When I touch there, I've got noise. So you know what? I think we've got a dry joint. I've got potential dry joints on two other pins. Right, I'll switch back on. Oh look, we've got normal audio. Well, that was an easy fix, wasn't it? I won't have to charge him £1 million more for the diagnosis. So does that bring us audio back? Wallow. Yes, it does. Good. So deviation Wow, it's 3.5, so that needs to come down. I'll have to get our sheet out next to see what adjustment does what. So it was 3.5. I'll do that right away. Pause the video. Right, so that's got everything we've got. This is all we have for the Cybernet Beta. We've got the circuit, we've got the photo, we've got the adjustments. This is, what we've had to produce. So here we go. We'll start with the transmitter. T2, T3, what's that? Can't see. T4. So making sure we're on channel 20. We'll go on to the other scale now. That is a broken core. Just see whether we can deal with that. Let's start. Tap any debris out. But it's in the correct position. Now as the set's warmed up, we're getting less output, as you can expect. So I think we're going to have to compress that core, that coil. We'll change its position. So that's brought us up to 3.1. Now that's stretched, but it may need compressing. It does. Compressing that has brought us up. Change its position slightly. So that was, I don't know why that was so far stretched, but it was stopping the radio being on 4 watts. But you can see in the photo that they're adjusting the PA with the top 3 rings of that coil, which is what I've just touched there, and this. So this is how it's done. I'm dead against this type of thing, but Maxon do it as well, and I suppose all the new sets do that because they're too cheap to put anything in. Adjustable. So we've got a full 4 watts now on channel 20. So it'd be nice if it was within 0.1 on the other channels at the band edges. So we've now got 3.9. I could say 3.92 or something like that. We're going to say 3.9. Normally you tend to get more power at the lower end, so we'll see what happens at the high end. It's spot on the 4. So that's absolutely fine. So now on low power, go back to channel 20. Now on low power, I've got to find the pesky little switch. It's dropped. How can that be? It can be because the preset's dirty. Just like in the Cybernet 134 chassis. So we'll waggle that around. High power, low power. Yeah, we're fine. 400. And the power consumption is now 540. milliamps. So we're now at 400 milliwatts. I could say 405, but I won't. And the power consumption for normal power is now 1.12 amps. So we'll do the deviation. They've basically cranked that to full. Wallow. It's still a little bit over the top. Wallow. It's a bit under now. Wallow. That's exactly where I want it. Now then, let's get out the other mic. Wallow. Yes, a little high with that mic. Wow, now it's a little low. I'll put that one back on the shelf. Wallow. Wallow. That's it. Wallow. There we are. That's where we are. Good. And have we got receive working through this mic? Yes, we have. So this mic's fine. Good. So the power meter on the front of the set, you've got two at the front here, and it's the front one. So we want this so it's just for, will it do that? No, we're going to have to do this on low power, so it's 1. So we're set for 1 on low power, and it's all 4 on high power. So we'll have to look at the instruction book for what S9 is supposed to be on this. Now the receiver is already really good on this, but we will nevertheless be going through it as we normally would. So we'll start with putting an S9 signal on the test set. Now we're on frequency, we need to set the signal generator to be on frequency. So that's now reset for 27.79125. We'll look at our oscilloscope. We need to plug the test equipment in instead of the PA speaker on the wall. Talking of those speakers, our mystery benefactor Alan kindly sent us one a few weeks ago, and I'll just show you that. We'll test it while we're at it. Okay, so there's our waveform for recovered audio. Just have to look at our other crib sheet as to which is the detector. It's T12. Absolutely miles out. So that would be T6 in other models, but not this one. Let's go over to the Cybernet meter and get about 4 dBs. Put the bench light back on. Start with T5. Drop the attenuator. These have all been dealt with in the past by somebody. Put a bigger signal on. I think that's about where we are. So let's see what we've got for sensitivity now. So for 12 dB, we've got 0.39 microvolts. For 10 dB, we've got 0.31 microvolts. We couldn't get 20 before. We've actually got 20, looks like 1.1. Just change scales. It is, it's actually 1.05. Very good. So the squelch threshold, turn the squelch to full. That wants tightening up a bit. So squelch is the preset there. Excellent. Now we'll do the other end. And hopefully with all this IF retuning, as well as the front end, hopefully the squelch will sound right now. So we'll put the signal generator to standby, set the squelch, switch the signal generator back on. 2.4 microvolts. It's not, it's 0.2 for you, Wally. Just need to get an instruction book and just see what that says. Right, I've looked at the instruction books for the Beta 1000, Beta 2000, even the Beta 3000, and the Radiomobile 202, which we do have on file. I haven't got any of the Ford ones on file, and there's no mention whatsoever of what the it just says relative signal strength. So it's make of it what you will. So 1. At the moment, that's coming in at what? It's coming in at 30 microvolts. Shall we set that to 100? Just to make it a bit more meaningful, yeah. There we go. So we've set that, the fourth one, to S9. 4 equals S9. There we go. Let's hope the internal speaker works. Just pop the power off while we put this on. They're smaller speakers in these than most sets of the era, but they're on a par with the size of the speakers that are currently in CB radios. Right, we'll get the screws back in. The bigger version of this, the Radiomobile 202, was one of the more expensive sets at $119.99 as a recommended price. I can't remember what these were, but they certainly weren't bargain basement prices, and they were imported, etc., by Thorny MI. Sorry, I'll start again. The Cybernet ones, which were marketed by Goodman's, at the time Goodman's was part of Thorny MI. So presumably Radiomobile were Radiomobile. London NW27JS, made in Japan. Good. Right, we'll unplug the test equipment. We've got a lot of organ to do today. We've been waiting for a piece of mahogany to be, I was going to say manufactured, but cut and planed exactly. I just don't have the machinery for that, and that arrived yesterday, so we'll be doing the 15th today, fitting that onto the putting this veneer on the rack board. By veneer, I mean 10mm thick veneer. One and a Roger. Notice he's over deviating or off frequency. 19 a Roger. Right, well, we'll do a scratchy corner test much later on. It's 10:15 in the morning. So nice set. That's turned out really nice. And I've started to think there's something scary going to be wrong with it, but it wasn't so. So thank you for watching the Radiomobile CB201 using the Cybernet 135 chassis from 1981.